Thank you, David. Good morning, everyone. Pleased to be here in Dresden. Hopefully you'll find this presentation interesting. It's more about emissions and the environment than it is about technology, but let's see how we go. So really, I'll start with just a resume of the air quality challenge, then look at some of the off-highway limits and cycles, which I'm sure you're all familiar with, and then really go on to compliance. Where are we with off-highway engines on compliance, and how does that compare with on-highway? And finally, just a few words about the need for a holistic approach. So really, as far as an introduction is concerned, there's been a lot of bad press for diesel engines recently. Obviously there's a Volkswagen scandal, but also following through from that, the test cycle inadequacies for cars, meaning the compliance factors are very poor on NOx emissions for many cars. I think it's worth saying that air quality is important for society and we must support measures to improve it. But we need to be objective and holistic, because there are many contributing factors and many interactions which I think we in the industry understand, but certainly the press are happy to ignore. Certainly in the UK currently, NO2 is the focus. Many cities in the UK don't meet NO2 air quality limits, and really a lot of that is tied to road transport. So NO2 levels have fallen in the UK and in cities, but not as fast as expected. And this is largely due to much higher real driving emissions than certification levels for cars, buses, trucks, and possibly some other equipment. So this is a picture of London, and you'll see from the scale the NO2 levels. This is the mean annual level, and you'll see it gets worse towards the middle, but it very much tracks the roads. So hence it's largely a road transport induced issue. When we look at the apportionment of NOx in London in 2013, this data is 52% came from road transport. And really 8% is the estimate, and there's some questions about the modelling to generate these numbers, but 8% is the estimates come from NRMM, and most of that from mobile equipment. And of course the contribution from diesel is very high. Most of that is from diesel. So in terms of the UK NOx inventory, you'll see this scale, it's not very easy to read, but it starts back in 1990, and you'll see the NOx levels, the NOx amount of NOx generated is falling relatively quickly. And the green part there is transport. So that's probably falling the fastest. And projections show, without doing anything very different to what's planned at the moment, road transport contribution will be less than 50% in a few years' time. So many people think the NOx levels are going up, but they're not, they're going down. It's just not going down fast enough, or as fast as expected. I mean, there are other major contributors, and certainly in the UK, a big contributor about which little's being done is domestic heating. So a lot of gas is used for domestic boilers, and that's quite a big NOx contributor. So if we move from that general picture of air quality to NRMM off-highway, so a look at the limits and cycles. Many of you will be very familiar with this, of course. So this is a picture which we will know, but just reflect on that journey. It's a 20-year journey. First legislation came in 1999, Stage 5 comes in 2019, 2020. So in that 20-year journey, a massive change in the certification level of emissions. You know, by factors, if you multiply them by factors of hundreds in reductions. So when we get to stage 5, or where we are at stage 4, the engines are pretty clean. And if you would factor those levels of emissions into the inventory for all the machines and vehicles in London, for example, the contribution from those engines would be minimal. So the off-highway test cycle, which is a transient cycle, has been for the last couple of stages of emissions. Only point here really to look at is it covers most of the map. This was obviously derived as an EPA generated thing. They got Southwest Research to log various pieces of construction equipment and came up with this area of the map to cover. So it covers a pretty wide range of operation. We have not to exceed as well, so that's another constraint. If we look at the truck cycle, again it's a cycle which covers most of the operating range which trucks work on. And the point about these two cycles, these off-highway and heavy-duty on-highway cycles, is that they're pretty representative of what the machines do. When we come on to cars, the NEDC was the cycle used for many, many years, and it's only just now moving to the WLTC. But you see, the NEDC only covers a very small part of the map, and most cars operate outside that map. So that's the reason why the real driving emissions for cars are, massively higher than the certification levels. Obviously, there's process and legislation in place to change that, and when we get to 2020, I think it is, for cars, they need to pretty much cover the whole map, because they'll be subject to PEMS testing. But that's obviously a rapid journey that the car industry has to go on. So the people, the sector which is furthest ahead, I think, in terms of compliance factor or real use emissions compliance is obviously heavy-duty truck. They, at Euro 4, Euro 5, they were criticised heavily for compliance factors, and for Euro 6, that sector really came in line. So this just shows, really at Euro 4, the average real-world cycle was 2 times the certification limit. At Euro 5, it was a bit more than 2 times. When we were at Euro 6 and we look at the compliance factor on Euro 6 trucks, it's much less than 1. So that really shows what can be done in terms of applying the technology to achieve real driving emissions compliance. This is a test Ricardo did to demonstrate that. They PEMS tested a variety of buses in Brighton on this Route 7. Euro 4, Euro 5, there was a Euro 5 hybrid. There was a Euro 3 with what you'd call a well-matched high-quality retrofit, and then a simulated Euro 6 with an Iveco truck. And you'll see that there's a bit of improvement, Euro 4 to Euro 5. You get a little bit out of a hybrid, not a lot. If you do a really good retrofit with SCR and DPF, it's an improvement. But you apply Euro 6 technology and it brings it down to very close to 0. And many other people have done similar tests. There's a well-publicised one that Transport for London did a few years ago on one of the major bus routes in London. It showed pretty much the same results. So if we start now talking about where the different sectors fit together, this chart is PEMS testing, which Ricardo have done with various people, and the left box is NOx and the right box is NO2. Obviously, from an engine and vehicle emissions point of view, we measure NOx. From an air quality point of view, we measure NO2. So the relationship between them is important. If we look at the detail there, the left-hand column is a 20-ton excavator at stage 4. This was a JCB excavator they tested, and the level of NOx emission there is well within the certification level on this PEMS test. As is a Euro 6 truck. Earlier trucks and cars are above or at certification levels on PEMS. Interesting point here is if you look at the JCB excavator, the NO2 portion of NOx is about 20%. So you see a 0.03 grams per kilowatt hour NO2. And there's another point we'll talk about a little bit later. You know, the technology used on that is SCR only, right? So there's no DOC, no DPF. So you get a low portion of NO2. This one just shows CO2. Fairly obvious in some ways. The first one is the excavator, the second one's a truck, third one second one's a backhoe loader, third one's a truck. Various buses, you'll see a good result from a hybrid bus there at 404. And what stands out obviously is the gasoline car, much higher CO2. And obviously, car industry also has a big challenge in terms of their real driving CO2 numbers. This is just talking about those data sources. Coming on to construction equipment duty cycles, you see three plots here, which is from JCB log data. The first one's a backhoe loader on a general cycle, which we call a wheelbarrow cycle. Shows the usage pretty well spread over the map. Because it's a multi-purpose machine, it's doing lots of things in terms of a bit of loading, a bit of excavating, a bit of roading, etc., etc. The next one to the right, top right, is a telescopic handler, but on this cycle it's on a rehandling cycle, so it's similar to a loading shovel. And bottom left is an excavator, so you see pretty much constant speed. This is on a fairly high output excavator cycle. So the point of this slide is to show that you can see those three different types of cycles, and you can pick out in the NRTC the sectors of those real cycles which are reflected in the NRTC. So the NRTC is a reasonable representation of real construction equipment duty cycles. And the inference from that is that compliance factors should therefore be good. Now just a few words on the need for a holistic approach to regulation. I've called it a story of unexpected consequences. So, you know, exhaust emissions from combustion engines contain a variety of chemicals, and some of these are subject to legislative control. Techniques used to reduce a particular chemical can increase the production of others, we all know that. So there's trade-offs between NOx, NO2, particulates, hydrocarbons, CO2. And of course the regulations need to consider all of them if you don't want to avoid undesirable outcomes. And the regulations don't consider all of them. This is a slide which is put together for another purpose, but it basically shows, it's comparing emissions between different cars, Euro 6B, a Euro 6C/D, and a Euro 6 GDI. And the top column is particulate number. And, you know, real-world particulate numbers from diesel engines are very low because they have filters. But real-world particulate numbers from petrol cars are very high because they don't have filters. And when you go to a GDI-type combustion, you generate lots of ultrafine particles. In terms of real driving NOx, obviously the earlier diesels are high, the compliance factor is improving, the petrol has a compliance factor better than 1 generally at Euro 6. When you look at CO2, if diesel is 100 at Euro 6B, it might get slightly worse at Euro 6 CD, but obviously the petrol is much worse. Just as a reference there, we did a calculation of what the stage 4, tier 4 final JCB engine would be on a car-based grams per kilometre, and really it comes in at about 60 milligrams per kilometre. So if you could use that engine in a car, not that it would fit in a car, you could achieve a good compliance factor. And the same would apply if you could put with the Euro 6 truck engine. You'd achieve a good compliance factor. So really the conclusion of this is, in terms of the consequences, is that the latest diesel engines are very clean on particulates. Certainly the focus in the UK has been on NOx and NO2 and incentivising the sales of petrol cars. So that might have an improvement in NOx and NO2, but it's a serious degradation in ultrafine particulates. That's just a chart really showing the particle number count at 50 kilometres an hour when you compare. The black there is diesel with a filter. That sort of orangey colour in the middle is direct injection gasoline. And if you want to do a test, go and look in the car park. The cars with clean exhaust will be diesels, and the ones with dirty exhaust will be petrol. Another issue is, we mentioned it earlier, is the NO2 proportion of NOx. So the NO2 is the reagent, the chemical, if you like, which is monitored for air quality because it's regarded as the one which is most hazardous to health. But obviously combustion engines emit a mixture of oxides of nitrogen. My understanding is, though I'm not a chemist, is that the oxidation rate from NO to NO2 is quite slow when the concentration is low, which it is when the exhaust gets into the air. So conversion rate from NO to NO2 is slow, such that it would disperse before it can affect people's health. So the NO2 emission is quite important. So there's quite a lot of activity in recent years in terms of retrofitting DPFs onto equipment. And that obviously has, or can have, a very good benefit in terms of particulates. But generally, if you fit a highly catalysed filter onto an engine, it'll increase the proportion of NO2 from something like 20% to something like 50%. So by doing that, you double or triple the amount of NO2 that engine or machine is emitting. So nobody discussed this or thought about this at the time. It might still have been the right thing to do if particulates were an issue, but nobody really considered the consequential effect on NO2 of fitting particulate filters. So a very brief look at the future, if you like. Where can we go in terms of ultra-low emissions? There aren't many standards around. This is a CARB voluntary on-road ultra-low emission standard. So the NOx number is 0.027 grams per kilowatt hour. Particulate number is 013, which is probably not very challenging, but in the US they have less emphasis on particulate, it would appear. So the NOx number there is 5-10 times lower than a Euro 6 or a Stage 5 real cycle NOx. So can you achieve that? This is a bit of a data from a PEMS test we did on a 20-ton excavator. And the green line is the catalyst temperature, and this is a lorry loading cycle. So the excavator is just loading into a lorry. So you see that cycle on the catalyst temperature fairly plainly. The red stroke black there is the NOx, tailpipe NOx. And almost all the NOx contribution. So remember this one, when we PEMS tested this on a cycle basis, it was well within compliance to the certification levels through a mixed cycle of PEMS testing. So when you look at this working cycle in terms of lorry loading, almost all the NOx contribution comes from the, if you like, the start-up, i.e. from when the machine might be sitting stopped or idling. You start it up or you move it into action and you get that peak on the left-hand side of NOx. So almost all the cycle NOx comes from that part of the operation. So if you want to get to the very low levels of real NOx emissions, you need to get rid of that as much as you can through thermal management. You also see a little bit of NOx emission coming in later in the cycle, which really is needs developing out in terms of transient control and storage in the catalyst. But when you look at cycles like that, it seems that there is a further step possible in terms of significant reduction in NOx emissions. Batteries. Batteries. So people say, well, don't bother with all these combustion engines, just use batteries. So interestingly look at how much battery capacity you need to do a shift of work. So a mini excavator, 10 to 20 kilowatt hours, so that should be okay, might be able to do that. Because cars are at maybe 60 or 100 to do 250 miles. But even when you get into sort of smallish to medium construction equipment, the battery starts getting big. So for a backhoe loader or a telescopic handler, perhaps up to 200 kilowatt hours you need. And then if you look at a bigger excavator, 1,000 kilowatt hours. 1,000 kilowatt hours is quite a big battery. So probably for larger construction equipment, battery electric machines aren't really feasible at the moment. Summary. Sorry, this print's a bit small here. So I'll just say in conclusion really that urban air quality is an issue that needs addressing by industry as well as the regulators. High NO2 and particulate levels in cities have a major contribution from combustion engines in road transport and other machines. Modern diesel engine technology dramatically reduces emissions of these pollutants. The contribution to air quality comes from old engines. Off-road, off-highway regulation and engine technology is now in line with heavy duty on road, so the emissions regulations are pretty much all the same now for different applications. Real driving emissions in diesel cars have been much higher than certification levels due to the legislative cycle being unrepresentative. This is really being addressed now by the light-duty automotive industry. Heavy-duty on-road compliance factors are less than 1 at Euro 6, showing that real-world emissions can meet or better certification levels. Off-road EDRMMM at stage 4 and 5 uses similar technology and can give high levels of compliance. Diesel technology can deliver further significant reductions in NOx and PM. And my final point really is that diesel engines offer high thermal efficiency and should be part of a low carbon future using renewable fuel sources. Obviously the carbon part of it comes from the fuel, and we shouldn't throw the diesel engine out because it offers many advantages. Just like to say thank you to Ricardo for some of the data in these slides. Thank you.
Right, thank you very much, Alan. If we've got questions from the floor. There must be some, surely. I think I'd just like to start with a comment. You know, one of the phrases I picked up when I was in Holland was "meten is weten." To measure is to know. Yeah. And how nice to see you've measured and you know.
Yeah.
And I think what I've seen over the last 20-some years of diesel engine development, I've seen exactly the same. It's been quite incredible, and it's been really quite distressing to see the poor press and how they've handled it. And thank you very much for producing this. Questions, please. Oh.
Okay.
I think you've covered the subject very, very well. I don't think I'd struggle to dispute anything of what you've presented there. Thank you very much. If we could...
Thank you.